Good day, ladies and gentlemen. This is Salo van Grenen, aka Mr. VG, and we are into our second video with analytical geometry, specifically looking at the Gauteng Department of Education exam of 2020, their paper 2. So in this video, we are going to dive deeper into, what kind of questions can they ask and what do you need to remember, especially from grade 10. So when we look at this question, I want you to try this question yourself and go for it. And, if you get stuck somewhere, I encourage you to try it once or twice before looking at the rest of the video. So yes, hit the pause button, try it yourself. So when we get a question like this, ladies and gentlemen, I love to first analyze the question. So I make 100% sure that I don't miss what is required of me. So when we look at this question, it says here, in the diagram below, P, negative 3, 17, Q, O, and S are the vertices of a parallelogram. So in other words, PS is parallel to OQ, as well as PQ is parallel to OS. And look, if I need it, alpha is also the size of angle P. Okay? So it's not necessarily that we are going to use it, but it's maybe something for you to remember. Let's look at what implications are there also about the parallel lines. Well, it says there the sides OS and OQ are defined by the equations y equal to 6x and y equal to negative x. What do I know about those two lines? I know that the y-intercept is at 0, which makes sense on my sketch, but also that the gradient of OQ is negative 1, and the gradient of OS is equal to 6. This means that the gradient of PQ is also going to be 6, while the gradient of PS is negative 1. That is going to be important later on. So let's quickly start with the first question. Determine the equation of QP in the form y equal mx plus c. The beautiful thing is, remember, for you to get the equation of a line, what do I need? I need a gradient and I need a set of coordinates. Fortunately, I have a set of coordinates. Oh, but wait, sir, I have a gradient, if I think about it carefully. So if I look at this question, I'm going to start by saying, well, the gradient of QP is the same as the gradient of OS. So therefore, the gradient of QP is 6. So I've got y equal to 6x plus c. To determine c, I just need a set of coordinates. So I'm going to make y 17 and x to be negative 3. This means solving for c is going to give me that y is equal to 6x plus 35. Awesome. Easy, straightforward. Now, I want to quickly go back to that, to the previous slide. It says there, determine the coordinates of Q. So in other words, how do I get Q? Remember what you just calculated. Remember, you just calculated the gradient or the equation of PQ to be y equal to 6x plus 35, okay? So when I look at this sum, here's a very, very crucial bit of information for you to remember. If I calculated something in 4.1, there's a very big chance I'm going to need it in 4.2. Remember that, especially in paper 2. So what does Q have in common with all the information that I've been given? Well, I can tell you that looking at this, okay, if I look at where I am with y equal to 6x plus 35, Q is the point of intersection between y equal to negative x and y equal to 6x plus 35. And this is actually, I want to say in inverted commas, level or not level, paper 1 knowledge, because it's just the intersection point between two graphs. So how do I determine that? Well, I make them equal to one another. This means solving for x, that I have x to be negative 5. Not done yet. We need a set of coordinates, so I need x and y. So I'm going to substitute back. Let me choose the easiest one, y equal to negative x, which gives me q as being negative 5, 5. Not that bad, ladies and gents. Not that bad at all. Let's look at the next question. It says now calculate the length of OQ. Fortunately, I've got both equations because remember Q is negative 5, 5 and O is 0, 0, which leads me towards the equation where I go 0 minus negative 5 squared plus 0 minus 5 squared, which is 5 root 2. I'm going to leave it as is because it says simplified third form. Leave it as is. Now, 4.4 actually has got nothing to do with 4.3. Okay, it kind of sucks, but it doesn't. Because when I look at something like question 4.4, what I like to ask myself is, what lines does alpha touch? Remember I asked that in the previous video as well. Which lines does alpha touch? Well, alpha touches OQ and OS. Therefore, if I look at the inclination angles, the first inclination angle, which is of OQ, is from the positive x to OQ. Then let's call that theta. The second inclination angle of OS is from the positive x to there, and let's call that beta. Here's a beautiful trick, ladies and gents. A beautiful shortcut. Even if you don't know how to get to alpha, you get the gradients between O and Q, you get the inclination, and you are going to score almost all the marks. Fortunately for us, we can just say, well, to get theta, I already have the gradient. So that is negative 1. Putting it into the inclination angle formula, if I solve for theta, then I have tan to the negative 1 of negative 1 plus 180 degrees, which gives me 135 degrees. That is now theta. Beta is 6 tan beta. Okay? So in other words, beta is 80,54. Now, here's the question. What is the relationship between alpha and beta? Simple, that alpha is beta or theta minus beta. Okay? So, if I look at alpha, it is simply the difference between theta and beta. So if I subtract those two from one another, I get 54,46 degrees. And that is basically the gist of how to work with these kind of angles between lines. Always check which lines they touch, get gradients, get inclination, calculate that inclination angle, and then use either common sense or geometry to solve for that angle in between. Let's look at the next question. Now, the next question, ladies and gentlemen, is if OS is the root of 148, okay? And the question is calculate the length of QS. Now, what I just did there was I filled in all the information we've gotten so far, okay? And I've added the line that they're asking me to calculate QS. And then I'm kind of now wanting to go bull in a china shop, okay? What does bull in a china shop mean? Well, bull in a china shop means that I just want to run headlong into that. I want to use the distance formula. The problem is that I've got Q's coordinates, but I don't have S. So in other words, I cannot go directly into QS. But also, ladies and gentlemen, it only counts 3 marks. So if I want to try and calculate S's coordinates, man, that's going to be tough for 3 marks, okay? To get S's coordinates on its own is going to be about 4 marks, 5 marks. Not even talking about getting the distance between them. So this means I've got to try and think outside of the box to get those 3 marks. So what I'm thinking about is, isn't there some kind of formula that I could use? Oh, most definitely. In that triangle there, I could simply use the cosine rule because I'm trying to calculate the third side. So calculating the cosine rule, it is simply O squared is Q squared plus S squared, okay, minus 2 SQ times cos of 146. And I've just substituted the values in. This is going to give me QS as being the root of 100,005 ... You'll see I put a root on both sides simply to get rid of the square. This gives me a final answer of QS being 10. Woo! This was a bit more of a tricky kind of sum, okay? It used a lot of different kind of thinking, and I love it. If I was your teacher, your examiner, I would definitely ask a question like this. Definitely. Ladies and gents, I hope you enjoyed this video. And I hope you're taking some golden nuggets from this video. Because this is the same thinking I teach matriculants, straight through to get them to make a success of mathematics. So have a beautiful and amazing rest of your day. And I hope that you're going to be ready for the next sessions, the next set of videos about trigonometry, about Euclidean geometry. It is awesome that you have stuck through so far. Continue pushing. You are going to have success if you don't give up. So have a beautiful rest of your day. Keep well. Bye-bye.